So let's now move on to a slightly different type of problem where we're now given a question where we have to find the equation of the line through these two distinct points. So for this one, we're again going to use this y is equal to mx plus b, but it's a little bit more work this time, because first we have to find the slope. And in this case, we can't actually count it. So we need the slope formula for this, which you might recall is essentially the difference in the y values, y2 minus y1, divided by the difference in the x values, where you start with these points, x1 comma y1 and x2 comma y2. And essentially, we just have to figure out, given these points, which ones do we want to call x1, y1, and which do we want to call x2, y2, and then we just plug these in to find the slope of the line. So once we find the slope, then we can just use one of these points, plug it into this general equation, and essentially solve for b. So let's actually start doing that. So with these 2 points, I'm first going to label what I want to call my x1 and y1 and what I want to call my x2 and y2. So for this first point, I'll call this one x1, and that essentially makes this one y1. The subscripts have to be the same for each given coordinate pair. And if I called these x1 and y1, that would make this x2 and this one y2. So at this point, you just have to plug into the formula. So y2 is this negative 4. And then we subtract y1, but y1 is negative 5. So we're subtracting a negative here. You want to be very careful with your signs. And then on the bottom, we have x2, which is minus 4, minus x1, which is minus 6. So this one is a little tricky because of all the different negative signs. But when you're subtracting a negative, it's the same as adding. So we are adding in both these cases, in the numerator and the denominator. So minus 4 plus 5 would just give us 1, and minus 4 plus 6 would give us 2. So we found that our slope is equal to 1/2. So let me just make a little bit more room, because at this point we're going to plug in that m value for our slope. So we have y is equal to m times x, but m is now 1/2 times x plus b. And at this point, the x and y values here, these are the variables, so they're always going to stay in the equation. But this value b, this is the y-intercept. And essentially, we just need to find it. So what you can do at this point is you can pick either this point or this point and essentially plug it into the equation. Since essentially, let's choose this point right here. So essentially, we have an x value and we have a y value. So if we plug in for y, where y is equal to minus 5, and we plug in for x that it's equal to minus 6, then we can essentially just solve for b. Though the truth is, you could also use this point as well, plugging in minus 4 for both x and y. So let's actually substitute these values into our equation here. So y is minus 5, and then we have 1/2 times x, but x is minus 6, and we have plus b. So now we just want to solve for b, so I'm going to simplify. So I have minus 5 is equal to minus 6 divided by 2 would be minus 3. And from here, I'm going to add 3 to each side of the equation. So minus 5 plus 3 would be minus 2. And minus 3 plus 3, these cancel, and I'm just left with b. So I found the y-intercept to be this point negative 2, or essentially it goes through at an x value of 0 and a y value of negative 2. And with this, we can complete our equation. Since we already know what m is, now we just have to substitute in what b is. So we have that y is equal to 1/2 x plus b, but b is this negative 2, so we have minus 2. So this is the equation of our line, and you can test this by plugging in the point that you didn't use. So we use this minus 6 minus 5 to find b, but now if we plug in this point, then we should get back negative 4. So in other words, if I plug in negative 4 for x, then I should get a y value of negative 4. And if that's the case, then we can feel very confident that this equation is correct. So let's actually plug that in. So we have y is equal to 1/2 of minus 4, since that's the x value I'm plugging in. Then we'll subtract 2. So y is minus 4 divided by 2, which would be minus 2. And then subtracting 2 from that, and we get minus 4. So our test was correct, which tells us that we can feel very confident that this equation is right. And let's do one final problem. So let me just scroll down and scroll back over. So we have this problem here where, again, we have these two different points, and we need to find the equation of the line that goes through them. And one thing you could do to at least help you visualize this is maybe just draw a picture, because we can essentially plot both of these points and then connect them with a line. And sometimes that helps just giving a visual of how to solve this, though the truth is what we did in the last problem is essentially the process or the method for actually finding the equation. But if you're ever not sure what to do, it can be helpful to draw a picture, or essentially to ask yourself, what can you do? So let me draw this picture really quick and then I'll plot the points. So now that we have this coordinate plane, let's first plot this point, minus 10, 3. So we go to minus 10 for the x value and then up 3 points. So that's that point right there. And then we'll graph this minus 8, minus 8. So we go over 8 to the left on the x-axis and then down 8 on the y-axis. So we're somewhere right about there. And from here, we can just connect these with a line. So our line should look something like that. And this will at least give you some intuition on what our equation should be. And we can notice that our slope here is downward sloping as x increases, so that tells us we should have a negative slope. And our y-intercept, it looks like, would be a very negative number, though we don't know what it is yet. So now that we have this visual of what our line looks like, we can start trying to find the equation. And we know that we essentially are going to use this slope-intercept form, but we have to figure out what slope is. And we know from our previous problem that the formula for slope, when given two unique points, is just the difference in the y values divided by the difference in the x values. So when we go up to these points, we have to decide which ones are x1, y1, and which ones are x2, y2. So I'll call this x1, y1 for this minus 10, 3, and this minus 8 can be x2, y2. And so at this point, you just plug right into the formula. So we have y2 minus y1. So we have this minus 8 minus 3. So minus 8 minus 3 divided by x2 minus x1. x2 is minus 8. And we subtract x1, but x1 is minus 10. So be careful with your signs here. It's always helpful to put it in parentheses. And at this point, we'll just simplify. So subtracting a negative is the same thing as adding. So in the denominator, we get a positive 2. And in the numerator, we get minus 8 minus 3, which would be minus 11. So our slope is this minus 11 halves. We're going to plug that into our equation. So we have y is equal to minus 11 over 2x plus b. And at this point, we just need to find b. So I'm going to choose one of these points and plug it in anywhere I see an x and a y. So I'll choose this point, minus 10, 3. So I'm going to plug in minus 10 for x and 3 for y, and then solve for b. So I get 3 is equal to minus 11 over 2 times minus 10 plus b. Let me just make a little bit more room. So when we simplify this, we have minus 10 divided by 2, which would be minus 5. So this simplifies to minus 11 times minus 5 plus b. And when we multiply these together, we get positive 55. So 3 is 55 plus b. And then just subtracting 55 from each side, we get b is minus 52. And both of these results for our slope and our y-intercept are essentially what we expected. Since our y-intercept, we said, should be very negative. Like if you carry this down, it's not going to intercept this until you get to a very big negative number. But we also determined that this is sloping downwards as x gets bigger. So having this minus 11 halves, or minus 5.5 if you made it a decimal, this confirms that we do have a negative slope. So combining all of the information together, what we get is y is equal to minus 11 over 2x, and then plus b, but b is this minus 52, so we have minus 52. So this right here should be the equation of our line, but we'll test it. We're going to plug in this point, minus 8, minus 8. So let me do that down here. So anywhere we see a y and an x, we're going to replace it with minus 8. So we have that minus 8 is equal to minus 11 over 2 times minus 8, and then minus 52. So this should simplify to something that's true. Or in other words, we're trying to see if this right-hand side does simplify to a y value of minus 8. So let's test that. We have minus 8 divided by 2, which would be minus 4. So we have minus 11 times minus 4, and then minus 52. 11 times 4 is positive 44, and since we have two negatives, they'll cancel each other. So we get 44 minus 52, which is, in fact, negative 8. So our test point worked, which confirms that this equation is indeed the equation of our line given those 2 points.